Hola, me llamo Jacobo Arbenz.
Hola, me llamo Paco Batista, and we are going to introduce you to the wonderful world of physics.
See. Now, first, we would like to show you some important safety precautions that you always need to go through before any sort of physics experiment. The first thing you always need is your protective eyewear. Now, to protect your eyes, los ojos, and also it is nice to have some nose protection and some mouth protection, as seen here.
It's okay, my beard can deflect bullets.
Mucho.
Next, you need protection of your head. A helmet is nice, purple is preferable. Mi cabeza is very safe.
Bueno.
Very, very safe.
Always make sure it is securely on.
Very snug.
Perfect. And lastly, also you just need to have some extra very important safety precautions, as seen here.
Very safe. I feel very safe.
I'm safe.
Are you feel afraid?
No.
Just in case you need this, just in case atom goes haywire, bomb goes off, we are protected.
In today's lesson, we're going to be learning about fluid physics.
Yes, today we'll be discussing phases of matter, buoyancy, pressure, and flow. The three phases of matter are solid, liquid, and gas.
Of course. Now, solids have a definite shape and volume, such as this baseball. Therefore, they do not have the ability to flow, which makes them not a fluid.
Very good. Our next phase, liquid. It has a fixed volume, but can be any shape. Before we demonstrate an example of a liquid, we are going to need to take our safety precautions. Thank you. Do not try this at home, folks. Watch its ability to flow, making liquids a fluid!
Hey. And the last phase of matter, gases. They have no definite shape or volume, much like the air we breathe, making them also a fluid. Second topic for today is buoyancy. Buoyancy is the properties of that objects have to float in fluids. An important concept you must learn first to understand buoyancy is density. Density is defined as the object's mass divided by its volume, which can explain why objects do not float solely on their weight or size. The formula for buoyancy is buoyant force equals rho, the density, times the volume of the object, times gravity, which we all know is roughly 10 meters per second squared. Now, to help explain buoyancy, we've brought in a guest physicist today. May I introduce Sir Merlin the Wizard.
Hello there! I am here to help young Viking boy here with buoyancy. See, buoyancy is what is the float in something. It's what allows large boats to go on water without sinking. Okay, I am going to do a quick demonstration. I believe you need your safety precautions.
And what about you, Merlin?
I don't need safety precautions. I'm a wizard. I will show you. Is baseball a good American pastime? You think, wow, what a big object. I bet it will go all the way down. But watch. It floats. The ball floats. And I swear, no magic was involved. Just physics. Now you may think, look at this tiny golf ball. I could probably drive this 300 yards. Well, wait. As it is submerged in water, it sinks all the way down. The reason for this is the difference in the spherical object's densities and the surface area. You see, the baseball has a large surface area, so the force is dispersed among it, allowing it to be greater and has a greater buoyant force. Now, I must depart you, young lad. Archimedes is getting hungry.
Thank you, Merlin. Now, as you see, buoyancy is a very important part of our daily lives. We experience it all the time. It's why we feel lighter in water. It's easier to pick things up. It's the reason that submarines can go to different levels of the water, why boats float, and also why hot air balloons are able to rise, or a helium balloon. Because since gases, as you may recall, are also fluids, if they have a lighter density, will be able to float upward. Now to move on to our final topic of the day. And today's secret ingredient is pressure! Pressure is defined as rho, the density of the object, times g, gravity, multiplied by h, the height difference between the 2 points that you are measuring. As seen here, pressure is exerted in all directions on an object, and fluids will always flow from high to low pressure.
The real-life applications of the pressure are brakes, spray cans, water towers, and the super soaker!
Now, the reason that super soakers are able to function is that in the area that the water is contained, by pumping, air is added to the same amount of volume, therefore increasing the pressure inside. When the trigger is pulled, it opens a valve, which, by the fact that pressure is exerted in all directions, the fluids will try to flow outward to the low pressure outside.
The instrument that is used to measure pressure is the barometer!
Odomo. And again, mi nombre es Jacobo Arbenz.
Me llamo Paco Batista.
I hope you have enjoyed today's episode, learning about fluid physics. And I hope that you have also learned to always wear protection.
And see you again in another wonderful episode of the wonderful world of physics.
Bueno.